Today we're going to learn about measures of variation, section 2.4. Our learning targets are: I will know how to find the range of the data set. I will know how to find the variance and standard deviation of a population and of a sample. I will know how to use the empirical rule and Chbosky's theorem to interpret standard deviation. I will know how to approximate the sample standard deviation for a group data. I will know how to use the coefficient of variation to compare variation in different data sets. Range. Range is the difference between the maximum and the minimum data entries in a set. It must be quantitative. So it's the max data entry minus the min data entry. So here's an example. Corporation hired 10 graduates. The starting salaries of each graduate are shown. Find the range of the starting salaries. Well, the best way to do this would be to rank order them. So we rank ordered them. So the range is 47, which is the largest, minus the smallest, 37. 10. So the starting salary range is 10. 10 in thousands represents $10,000. Deviation. Deviation between the data entry X, doesn't matter which one it is, any X, and the mean of the data set. For a population, it's going to be X minus mu. Mu represents the average, the mean of the population, all of them. The sample data set, the deviation is X minus X bar, which is the mean of the data set, of the sample set. Alright, the corporation hired 10 graduates. The starting salaries of each graduate are shown. Find the deviation in starting salaries. Starting salaries are in thousands. Alright, determine the mean starting salary. Let's say this is the population. Okay, we're assuming this data represents the population. We add them all up. There's 10 of them. We divide by 10, so mu is 41.5. Then we're going to go into a chart. All the data entries, so it's 41 minus mu, 38 minus mu, 39 minus mu. Alright. So the deviation, those are all the deviations. The sum of the deviations will be 0. Population variance. It's the sum of the deviations squared divided by the total. So to actually solve for sigma, you would take the square root of sigma squared, which is the square root of the sum of the deviation squared divided by the population size, capital N. So, find the mean of the population. Find the deviation. Square them. Add them all up. Then divide by the total population, which will equal your sigma squared, and then take the square root of it. You will get the population standard deviation. Remember all these steps? It is very table driven. Alright. Finding the population standard deviation. Population hired 10 graduates. Here are all their salaries. Mu is 41.1. Alright. So we're going to do, we square each one of those. So we find the difference, the deviation We square the deviation, then we sum all the deviations, and we end up with 88.5. The total number of entries of our population, capital N, is 10. So we do the sum of the differences squared divided by the total population, which is 8.9. So the population variance is 8.9. The standard population standard deviation is the square root of the variance. Population standard deviation is the square root of the variance. So the population standard deviation is about 3.0 or $3,000 because it's in thousands. Sample variation. Sample variation is the sum of the deviation from the mean of the sample squared divided by the total number of sample items minus 1. And then the sample standard deviation is the square root of the sample variance. So first you find x bar, which is the sample mean, which is the sum of all the elements divided by the total. Then you find the deviation of each entry. Then you find the square of the deviation. You sum them. And then you divide by n minus 1 to get the sample variance. To get the sample standard deviation, you take the square root of your sample variance. Alright, so let's say this is a sample. Same numbers, but now we're considering them a sample. Sample size is 10. Alright, so we find the deviation, which is x minus x bar. We square them, we get 88.5 again. Our small n is 10, but now it's 10 minus 1, so our sample variance is 9.8. Now, our standard deviation is the square root of our variance, which is square root of 9.8 is approximately 3.1. The standard deviation of our sample is $3,100. Be very careful about these two different formulas. Keep track of whether it's population or sample. Using technology, find the standard deviation. Okay. So I am going to, with this data, I am going to produce another video showing you exactly how to use technology. So in our calculator, you put all that data. And then I will show you how we get all our standard deviations using the calculator. Standard deviation is the measure of the typical amount of an entry that deviates from the mean. So how far away is it from the mean? The more the entries are spread out, the greater the standard deviation. If everything was exactly the same value, your standard deviation would be 0. If it was spread out in like kind of like a little curve, like a little bucket curve, like a bell curve, you get a small deviation. But if it's really spread out, your deviation, your standard deviation would be larger. So look at these three pictures. Close, spread out, really spread out. For data with a symmetric bell-shaped distribution, the standard deviation has the following characteristics. 68% of the data lie within one standard deviation of the mean, left and right of the standard deviation. So that's plus 34% and to the left 34%. 95% of the data lie within two standard deviations. Okay, so that's an additional 13.5 on either side. And then 99.7% of the data lie within 3 standard deviations. So this is our standard deviation empirical rule. 68, 95, 99.7. This is something you should memorize. The blue is 1 standard deviation left and right. The tan is 2 standard deviations left and right. And then the addition of the green, which is 3 standard deviations left and right. And this is a bell curve. Green portions are 2.35%. This is the empirical rule. Example using the empirical rule. In a survey conducted by the National Center of Health Statistics, the sample mean height of women in the United States ages 20 to 29 was 64.3 inches, with a standard deviation of 2.62. Estimate the percent of women whose heights are between 59.06 inches and 64.3 inches. All right. So the average So between 59.06 and add 1 standard deviation is 34%. Add another standard deviation is 13.5%. So in this case it's 34 plus the 13.5. So in this case 47.5% of the women are between 59.06 and the average, which is 64.3 inches tall. So we're talking, if this is 64.3 and this is 59.06, you add up these 2 percentages to get the percent number of women that fall within that height. You do not subtract, you add them. Add this and this, so these 2, this area and this area added together represents 47.5%. Chebyshev theorem. The portion of any data set lying within k standard deviations, 1, 2, 3, etc., of the mean is at least 1 minus 1 divided by k squared. So if k is 2, in any data set, at least 1 minus 1 squared, which is 1 over 1/4. So 1 minus 1/4 is 3/4. 3/4 is 75% of the data lie within 2 standard deviations of the mean. Let's say 3 standard deviations, because k represents 3 standard deviations. So it would be 1 over 3 squared, which is 1/9. So that's 1 minus 1/9, which is 8/9, and 8/9 is approximately 88.9% of the data lie within 3 standard deviations of the mean. Using this theorem, the age distribution for Florida is shown in the histogram. Apply Chebyshev's theorem to the data where k equals 2. What can you conclude? Alright, so k is 2, so mu 39.2 minus 2 sigma, which is 24.8, which is the standard deviation, which is 39.2 minus 2 times 24.8, which is minus 10.4. Alright, since 0 age can't be negative, so use 0. Age can't be negative. So we go the other direction. So now we do the plus 2 sigma. So we go 39 plus 2 times 24.8, so 88. So at least 2 sigma, remember the K, at least 75% of the population of Florida is between 0 and 88.8 years old. Actually, negative 10.4, but remember, can't be negative, you're not born yet. Standard deviation for grouped data. The standard deviation for frequency distribution, so it's the sum of the differences squared times frequency, where n is equal to the sum of the frequencies. That's n minus 1. So when a frequency distribution has classes, estimate the sample mean and standard deviation by using the midpoint of each class. Alright, so we have all this data, children per household in a region. We're going to find the sample mean and the sample deviation of the data set. So construct a frequency distribution. Alright, so here is 0 times 10, 0. 1 times 19, 19. 2 times 7, and so on and so on. Total number of data points is 50. So the mean frequency distribution is the sum of x times f divided by n, the sample size. So it's 91 divided by 50, which is 1.8. The sample mean is 1.8 children. So now we do a table, determine the sum of squares. So we have x, which is the categories, f, frequency, deviation, x minus x bar, deviation squared, and then the frequency times the deviation squared, and we sum that and we get 144.4. So 144.4 divided by 50 minus 1, and then the square root of that. Our standard deviation is 1.7 children. So our mean is 1.8 children, and our standard deviation is 1.7 children. Coefficient of variation. The coefficient of variation describes the standard deviation of a data set as a percent of the mean. Population data set. Population coefficient of variation is sigma divided by n times 100%. Sample data is coefficient is s divided by sig x bar times 100%. So the table shows population heights and weights, members of a basketball team. Find the coefficient of variation for the heights and weights, then compare the results. Heights and weights. So mu is 72.8. Let's make a change here. There's a typo. I'm just going to copy you for now. Alright? That's what goes. Alright? So this is mu. Alright? So down here, this guy right here. Just gonna put a U there. Alright? Alright, so sigma divided by mu times 100%. So 3.3 divided by 72.8 times 100%. So variation of the height is 4.5. So the mu for the weight, goodness, why is this person? So weight is sigma divided by mu times 100%. So 17.7 divided by 187.8 times 100% is 94. If you're comparing the two variations, which one varies the most? Height or weight? In this case, the weights are 9.4% and the heights are 4.5%. So the weights vary a lot more, twice, almost more than twice than the weights. Alright, summary. We found the range of the data set, max minus min. We found the variation, the standard deviation of the population and of a sample. We used the empirical rule and Chebyshev's theorem to interpret standard deviation. We approximated the sample's standard deviation for grouped data, and we used the coefficient of variation to compare variations in different data sets.